Hello, welcome to Chapter 1, Section 8 as we try to wrap up Chapter 1 and get ready for things for next week. Introducing equations here. I'm going to go fast, so be ready. I'm going fast because you should know most of this stuff. Right? You've really probably seen all this before. It's not new, but I just want to talk through it, make sure we're on the same page, and you have an understanding of the vocab that they roll across in 1-8. Opposites. Opposites are basically two numbers. When you add them together, you get 0. They're the same distance from 0. They just go the opposite direction. Okay? Those two are not opposites, but those two are. If you add those two numbers together, 0. 0 and 1, those aren't opposites, but those two are. That's why we circled the first or the second and last one there. Number 2 says an equation. This is important here that you know that the word equation actually means that there is an equal sign there. Okay, the two sides or two things are equal. Two sides of an equation are equal. So that's why we circled these three. But we did not circle this one because you know what that's called? That's an expression. And I will expect you to know the difference between those two. Equation on the end, yes. Yeah, it's just 43 equals 43, but guess what? It has an equal sign. All right, number 3, use mental math to solve the equation. So you should be able to get all those numbers in your head there if you work those through. Vocabulary builder, solution. Yeah, that's really what most of this is about, that you get that. Here's your key right there. A solution is any value or values that makes the equation true. There's your key right there. If it makes it true, it's a solution. Interesting thing, we later in the year are going to see a lot of times where we can have more than one answer. Okay, there will be times we could have an infinite number of answers. You can never list them all. You can only graph them. That comes later. And we'll also have times where there are not solutions to problems right there. And there's an example of an equation where that is not a solution. 6, 7, and 8 you could probably do fairly quickly on your own, but I'll talk you through them real fast. It says cross out the equation for which 24 is not a solution. Okay, well, that one, last time I checked, 24 plus 4 was 28, and 24 minus 2 was 22, so those two are a solution. However, 3 times 24 does not equal 24. You can cross that one out, and that one's true on the end as well. Circle the equation for which 20 is the solution. So it is a solution. Right there, 20 divided by 5. Guess what? That's 4. That's true. Circle the solution of 7 minus x is 9. All right. You'll see they circled -2. If you recall your rules of subtracting integers, which you should know. If you subtract a negative number, boom and boom, it's the same thing as adding a positive. You'll need to be able to do that. Yes, you will. All right, there's your first page, 1 through 8. Hit pause if you need to go back, or hit pause if you need to copy that down, or if you need to go back and review, but hopefully you can roll right along to page 2. Here it is. An equation is true if the expressions on either side of the equal sign are equal. An equation is false if the expressions on either side are not equal. An equation that contains one or more variables is called an open sentence. There it is. All right, so let's look at what they're talking about right here. Got it. Is this equation, is it true, false, or open? Explain. All right, well, let's look and see. I need to hide that. It says, does the equation contain one or more variables? Well, it sure looks like it to me right there. There's one. Number 10, is the equation true, false, or open? Well, based on this up here, it's open because there is one or more variables up, like we said right there. And they're just justifying their answer here. 3y plus 6 equals 5y minus 8 is open because it contains a variable. It's open. You need to know that word. Open sentence. Number 11. All right, it says, got it. Is the equation 16 minus 7 equal to, whoops, I thought I had a pen. 16 minus 7 equal to 4 plus 5. Is that true, false, or open? Explain. Let's see. Well, let's look at this. 16 minus 7 is 9. 4 plus 5 is 9. Does that equal that? Well, according to this, yes it does. Okay, it's true. All right, is that equation true, false, or open? True. Why? Because 16 minus 7 is 4 plus 5. And last time I checked, 9 equals 9. Number 15. Got it? They say. Is this equation 32 divided by 8 equal to 2 times 3? Is it true, false, or open? Well, guess what? There's no variables. I don't think it's open. Explain, it says. All right. 32 minus 8 is 4. 2 times 3 is 6. All of a sudden, this just got real easy, didn't it? Are those equal? No, they're not. Therefore, this is false. All right. Clearly because those two things. 4 does not equal 6. At least in my world, it does not. Let's move on down to number 19. Identifying solutions of an equation. Is m equal to 1/2 a solution of this equation, 6m minus 8? 6m minus 8 equals -5. Okay, I already got some writing on here for you, but you can substitute 1/2 for m. That's what you should do first. That's what's going on in your brain. All right, and then over here on the right-hand side, you write 6 times. We'll just substitute the 1/2 minus 8 equals 5. You're wondering, is that true? Now I can simplify. All right, 6 times 1/2 is 3. 3, it's minus 8, but again, if you think in terms of addition, which I encourage you to do that, we'll deal with that later, plus -8. All right, 3 plus -8 is -5. Therefore, down here, you circle that it is a solution. All right, 1/2 is a solution of 6m minus 8 equals -5. Rolling on to page 3, we are booking it, people. The length of a ball court. Okay, this is an interesting one right here. The length of a ball court is 14 times the height of its walls. Okay. Write an equation that can be used to find the height of the model of the court that has a length of 49 centimeters. Okay, so we have this. This is the height, and they told us that the length of this court is 49 centimeters. Would you please draw that in your notes? You don't have to do the smiley face. But I want you to get in the habit, whenever you can draw a picture to represent the problem, okay, you're engaging another part of your brain and will get it into that memory, especially if you're a visual learner. But you all should do it anyway. It's very good for you. All right, well, let's talk through this problem in number 20. It says complete this model. Well, let's relate the problem first. Well, we've got the length of the model court, which was this, 49. And we know that that was equal to 14 times its height. Here was its height. So it says let h equal this. Circle your choice below. Well, h is not the area of the wall, right? And it's not the width of the wall, it's the height of the wall. Okay, so that's why we circled this one right here. Therefore, if the length of the wall, the length of the court is 49, we know that 49 equals 14 times h, which is the width. And now we can write this equation, 49 is equal to 14 times h. Okay, there's a nice little application for it. We could go ahead and solve that, which we'll do that later. But right now, it's just taking this equation, taking this situation and writing this equation. All right, I'm at almost 9:30 right here, 9 minutes, 30 seconds. So I'm going to start it and I'll wrap it up. The second video hopefully will be a little shorter than this one, but get her done. Bring your notes to class. Talk to you in a second.